Good afternoon. I'm Ashreya Ranchord and I'm a Year 9 student at Samuel Marsden. My experiment is called Amazing Woodlice. I wanted to research what sort of adaptations insects might have to navigate their environments efficiently. I decided to use woodlice because they have to escape hot and dry environments quickly. The best way to do this is by walking in a relatively straight line. There is evidence that woodlice do this by alternating their turns left and right. This is called turn alternation. A plausible mechanism to do this has been demonstrated and is called bilateral asymmetrical leg movements, which is where woodlice move their legs faster on one side than the other, causing them to turn. I designed a maze to see if they actually show turn alternation. In my maze, they have the option to make a left or right turn at each of 3 junctions. If they do show turn alternation, then they should go left, right, or right, left, right, meaning they'll end up in chambers A or D. In my experiment, I had 50 successful trials, and 30% of them ended up in chambers A or D. If my woodlice were walking around randomly, I would have expected only 25% to end up in chambers A or D. The difference is not statistically significant, therefore I did not prove that woodlice show turn alternation. There may have been a few reasons why I was unable to prove that woodlice show turn alternation, although other scientists have. Firstly, I kept my woodlice in a comfortable damp container before placing them in my maze, whereas other scientists have found that if you put them in a dry container, they are more likely to show turn alternation as they are trying to find a damp location. Secondly, the length between 2 junctions in my maze was quite long, and there is some evidence showing that woodlice are better at remembering to do turn alternation when the distance between turns is short. Thirdly, the paths of my maze were wider than the body of an average woodlice, meaning the woodlice were able to turn around and go backwards. However, other scientists used pathways that were narrower, and that meant the woodlice had to keep going forward. Fourthly, if I had a brighter, hotter light above my maze, this may have encouraged the woodlice to try and seek shelter, and the best way to escape is to use turn alternation. Fifthly, some people have shown that juvenile woodlice are less likely to show turn alternation than mature woodlice. This may be because this is something they have to learn. In my experiment, I used many juvenile woodlice when it may have been better to use only mature ones. Finally, I would use a larger sample size of around 200 woodlice for statistical power. In conclusion, there is good evidence that woodlice navigate using turn alternation, and if I wanted to design an improved experiment, I would create a maze with narrow paths and shorter distances between junctions. I would only use mature woodlice and place a hot light above my maze. I would keep the woodlice in a dry exposed container immediately before placing them in the maze, and I would have a larger sample size. Thank you for viewing my amazing woodlice experiment.